All right, let's talk inverses for a little bit. First of all, inverses are something you're quite familiar with, whether you believe it or not. An inverse is kind of the undoing of something. So let me give you an example. Let's pick a number like 5 here. And let's multiply it by 2. Gives you 10. Now, if you wanted to undo that, we would take 10, and what would we do? We would divide it by 2 to get the 5 back. So multiplying by 2 and dividing by 2 are inverses because the original number just came back. So another inverse, if you took a number like 3 and you added 2, you'd get 5. Well, what would be the opposite of that? It would be subtracting 2 to get my 3 back. Inverses are the undoing of each other. And so the idea is that if you want to find and work with inverses, then what you need is you need to either do or undo something. For instance, another good example of that is if you square something. If you square something, you get 9. Well, what's the undoing of that? What's the opposite of squaring something? You know what it is. It's the square rooting of something. And so we see that one is creating it and the other is undoing it. Now, actually, what's quite interesting, if you look carefully, let's create kind of a table of values for these two guys. Let's say we got squaring and we have square rooting. So if I put in the number 1, I get 1. If I put in 2, I get 4. If I put in 3, I get 9. So you'll notice that that's the effect on x. I've squared everything. Well, what's the opposite effect? Well, it's square rooting. So if I put in a 1, I get a 1. Now watch, if I put in the square root of 4, I get 2. And if I put in the square root of 9, I get 3. What I want you to notice is this switching aspect of the table of values. If you are a function and you have an inverse, your table of values will also always be reversed, just like this group is. So that's a huge clue in recognizing what is or what isn't an inverse. Just to show you one more example of that same idea, let's say this is x plus 5 and this is x minus 5. These are the inverses of each other, right? One is to add 5, and if you take 5 back, it's the undoing or the inverse. So if we put in 1, 2, 3, we get 6, 7, and 8. If you put in 6 minus 5, you get 1. If you put in 7 minus 5, you get 2, and 8 minus 5 is 3. Notice again, the table of values are completely flipped. The last thing about inverses that I wanted to show you is how to create one from an equation. So I've just been showing you easy inverses. What happens if we have y equals 2x plus 4, and we want to create the undoing of that, or the inverse of that? We begin by switching the variables. And the reason we do that is because now as I solve for y, I'm going to undo what used to be applied to the x. So it's kind of like undoes it. You'll see what I mean. Because the first thing we'll do is we will subtract 4 from both sides, kind of undoing the plus 4. The second thing we will do is to divide both sides by 2. That's undoing the portion of the multiplying by 2. So we divide by 2. And that just simplifies to x divided by 2 minus 4 divided by 2 equals y, or in other words, 1/2 x minus 2 equals y. This is the inverse of the original item. They undo each other. Let's do just one more example to make sure that it's clearer here. Let me just erase some of this stuff and get us into a starting position. Let's start with y equals 1/3 x plus 5. So the inverse is the undoing of that. And the way you do that is first you reverse the variables. By reversing the variables, you are going to undo it as you solve. So I'm going to subtract 5 from both sides, which puts me to here. Now, how do I undo a division? I do it by doing a multiplication. So I'm going to multiply this side by 3 and this side by 3. And ultimately, I get 3x minus 15 equals y. The reason that happens is because these divide each other out, and this becomes the inverse of this original item.